Welcome to the deep dive. Today, we're jumping back, way back, to the late Cretaceous. We're going to be digging into Mongolia's ancient past.
Mm,
And specifically, we're focusing on a dinosaur that's, well, still making waves, you could say. It's called Barsboldia.
that's right. And our main source material today is a pretty thorough scientific overview. It covers, how Barsboldia was found, how they tried to classify it, what we know about its body, and importantly, this ongoing discussion about where it actually fits in the dinosaur family tree.
Right, it sounds like a bit of a paleontological detective story.
Exactly. It's a puzzle.
Okay, so let's dive in. The story kicks off back in 1970. There was this Polish-Mongolian expedition out in the Nemegt formation. Can you just imagine finding something like this?
Oh, absolutely. Must have been incredible. But what's interesting is that their first identification, well, it wasn't quite right.
Oh, what did they think it was initially?
They thought the bones belonged to Saurolophus ingusirostris, which is another known hadrosaur from that area.
Ah, okay, so a case of mistaken identity at first.
Pretty much. It really shows how science works. You find something, you make your best guess, and then sometimes new information changes the picture.
And it definitely changed here. It took about, 11 years until 1981?
Yep, 1981.
Yeah.
That's when Teresa Marjaska and Hulska Osmolska, two Polish paleontologists, published their work. They looked closely and said, hold on, this is actually something new. And that's how we got Barsboldia sitchinski.
Barsboldia Sitchinski. I like how the names often tell a story, too.
They really do. Barsboldia honors Rinchen Barsbold, a really key figure in Mongolian paleontology, acknowledging his huge contribution.
Right.
And Sitchinski. That name honors Wojciech Sitchinski. He was the technician who actually prepared the fossil, cleaned it up for study. It's a nice nod to the essential behind-the-scenes work.
It absolutely is. Team effort, like you said. Okay, so this main specimen, the holotype, ZPL MGD 1110, it's from the early Maastrichtian age. What bones did they actually recover? What are we working with?
Well, it's not a full skeleton, but it's pretty decent. They got 9 back vertebrae, 9 hip vertebrae, 15 tail vertebrae, a left ilium that's part of the pelvis,
Okay.
parts of the pubic bones too, several ribs, and then some bits and pieces from the hind limbs. And crucially, a lot of the backbone was still connected, articulated.
Which helps a lot in figuring out how it all fit together, I imagine.
Definitely. Gives you a much better sense of the animal structure.
But like you said, not complete. What was missing?
Yeah, the big gaps were basically the front of the animal's skull, neck, front limbs, and the very end of the tail. Our source mentions that erosion likely took its toll over the millions of years.
Ah, the classic paleontology problem, working with what the Earth gives you.
Exactly. You piece together the clues you have.
So based on those clues, those bones, what did this Barsboldia look like? Can we picture it? How big are we talking?
Well, the first estimates, based on what they had initially, were around 10 meters long. That's about 33 feet and maybe 5 metric tons.
Yeah.
So, already a pretty big animal.
Decent size, yeah.
But then, more recent work, this is in 2011, looked at a specific bone, a tibia, a lower leg bone that was really long, like 1.4 meters long.
Wow, just the tibia.
Just the tibia.
Yeah.
And based on that, the size estimates got significantly bigger.
How much bigger?
We're talking potentially 12 to 14 meters long. That's 39 to 46 feet.
Whoa, that puts it up there with the real giants, doesn't it? Like Shantungosaurus?
Exactly. Right up there with giants like Shantungosaurus and Magnopolia. For a hadrosaur, a duck-billed dinosaur, that is seriously huge.
Absolutely massive. Any other weird or distinctive features they noticed on the bones they did find?
Yeah, there's something quite interesting with the tail. The first few tail vertebrae, the ones closest to the hips, have these sort of club-shaped ends.
Club-shaped, like thickened.
Thickened and rounded. It's similar to something seen in another hadrosaur,
Yeah.
Hyparchosaurus altispinus, and the source even speculates, this is just speculation, mind you, that maybe it's a feature linked to old age in this specific dinosaur.
Huh. Like skeletal changes as it got older. That's fascinating.
It's a neat idea. And of course, being a hadrosaurid, we know the basics.
Yeah.
It was a big plant eater.
Right, a herbivore.
Yep. Probably walked on 2 legs sometimes, 4 legs other times. And it would have had that classic hadrosaur dental battery, hundreds of teeth constantly replaced for grinding up tough plants.
A very efficient eating machine.
You got it.
Okay, so a massive plant eater, potentially reaching giant sizes. Now let's get into this classification confusion. You mentioned it's been debated.
Oh, heavily debated. So Marjaska and Osmolska, when they first described it, they put it in the Lambeosaurino subfamily.
Okay, and lambeosaurians. Those are the ones with the big, often hollow crests, right? Like Parasaurolophus.
Exactly. Think elaborate headgear. And if they were right, Barsboldia would have been the first lambeosaurine found in the Nemegt Formation, which was a big deal at the time.
But hang on. You said they didn't find a skull. How could they classify it as a crested dinosaur without the actual crest?
Ah, that's the million-dollar question. And that's precisely why the classification has been so tricky. They base their conclusion on features of the skeleton, other than the skull, the postcranial skeleton. They pointed to a keel, like a ridge, running along the bottom of the sacrum, the fused hip vertebrae. They thought that might be a lambeosaurine trait.
Okay.
And they also noted some general similarities in the shapes of the bones to Hypacrosaurus, which is a known lambeosaurine.
So they were using comparisons and other skeletal clues, but without the smoking gun, the crest itself.
Exactly.
Yeah.
And that lack of a skull, understandably, made other paleontologists hesitant. Over the years, because the evidence was incomplete, some researchers started calling Barsboldia a dubious genus, basically questioning if it was distinct enough.
Or just an uncertain lambeosaurine, maybe?
Or that, yes. A lambeosaurine, but we can't quite pin down where it fits within that group. So there was this cloud of uncertainty.
Until that 2011 study you mentioned earlier, did that shed new light?
It really did. This is a study by Albert Prieto Marquez. He did a big phylogenetic analysis, basically mapping out the evolutionary relationships of the whole Hadrosauridia group.
Okay, looking at the bigger family tree.
Right. And his analysis came to a very different conclusion.
What was?
He proposed that Barsboldia isn't a lambeosaurine at all. Instead, his analysis placed it firmly within the other main Hadrosaur subfamily, the Saurophina.
Saurophina. Okay, and those are generally the ones without the big hollow crests. Some might have solid crests or bumps, but not the hollow structures.
That's the general distinction, yes. Yeah. Think Edmontosaurus or Saurolophus itself, they belong to the Saurophinae. So this was a major shift in thinking about Barsboldia.
Wow, yeah. From potentially crested to likely non-crested. Does the study show where it fits among those Saurolophines?
It does. Our source mentions a cladogram from that study. It basically shows Barsboldia branching off in a group of clade with dinosaurs like Brachylophosaurus, the giant Shantungosaurus we mentioned,
right,
and Edmontosaurus. So more closely related to them, according to this analysis, than to Hypacrosaurus, which was the initial comparison.
So the family tree got rearranged, putting Barsboldia with a different set of relatives?
Pretty much. The analysis suggests it's a valid Saurophine. The cladogram also shows its broader relationships, placing it relative to other groups like Maiasaura, Cretaceous, and some earlier hadrosauroids, though the focus wasn't detailing every single branch.
Okay, this makes a big difference to how we imagine the animal, doesn't it? Whether it had this potentially elaborate head structure or not really changes things.
Absolutely it does. If it was a lambeosaurine with a hollow crest, you'd start thinking about visual display, maybe species recognition, perhaps even making unique sounds using those nasal passages in the crest.
Yeah, you can almost imagine these different calls echoing around.
Exactly. But if it's a Saurophine, as Prieto Marquez suggested, then those specific functions wouldn't apply in the same way.
But either way, crest or no crest, it was still a huge herbivore playing a big role in that late Cretaceous ecosystem.
Oh, undoubtedly. Regardless of the subfamily, a 12 to 14-meter hadrosaur would have been a major part of the fauna in the Nemegt Formation, processing lots of vegetation and likely being on the menu for the big predators there, like Tarbosaurus.
And this whole classification saga, the back and forth, it really underscores how paleontology works, doesn't it? It's always evolving.
It's a perfect example. You have incomplete data, a partial skeleton, missing key parts, like the skull and interpretations, can shift as new analytical methods are developed or more fossils are compared. It's a dynamic process.
So let's quickly recap Barsboldia. We've got this very large hadrosaurid from late Cretaceous Mongolia. Huge potential size.
Yep, potentially rivaling the biggest duckbills known.
Initially thought to be a lambeosaurine, one of the crested ones, but the lack of a skull made that uncertain.
Right, that missing skull is key.
And more recent analysis, based on the bones they do have, suggests it might actually be a Saurophine part of the non-hollow crested group.
That's the current thinking based on that 2011 phylogenetic work, yeah. A valid Saurophine.
It really shows how interpretations can change.
It absolutely does. Science correcting and refining itself over time.
Okay, so here's something to think about as we wrap up. Since our picture of Barsboldia is still based on that one partial skeleton, what kind of discovery would really settle the debate? What if someone actually found a Barsboldia skull?
That would be the dream find.
Imagine, how would that change our understanding not just of Barsboldia, but of the whole Nemegt ecosystem? And maybe more broadly, what does this whole story teach us about figuring out dinosaur evolution when you're missing crucial pieces of the puzzle? It really makes you appreciate every fossil fragment, doesn't it?
It certainly does. A good reminder that there's still so much left to discover out there.
Definitely something to ponder. Thanks for joining us on this deep dive.